at Unit 3.3, and this is when we started talking about genetics. We've already talked and reviewed over DNA, how DNA is made, what are the structures of the DNA molecule, and then we also talked about how we use DNA to make or code for proteins. In this section, we're actually in Unit 3.3, so if you want to use that to help you. In Unit 3.3, we're talking about genetics and heredity. So how do you inherit your genes? How do you inherit the traits that you have? In this first sentence, it says predicts, and this is what we need to be able to do, predict offspring ratios based on a variety of inheritance patterns. So remember that ratios, we're saying if there's a 3-to-1 ratio, maybe 3 people have the dominant trait, maybe 1 person or 25% has the recessive trait. A couple things we want to review over really quick is Mendelian genetics. In Mendelian genetics, this means that we have a trait that's dominant. We talked about one disease that is dominant, and that was Huntington's. Huntington's, and I know I wrote that really tiny. But in Huntington's disease, this is a dominant disease, meaning you just had to inherit one big H to have the disease. You could have also had a little h and been heterozygous. Remember, hetero means different. So 2 different alleles for the disease. However, you could have also been homozygous, which means you'd be big H, big H, big H, big H, homozygous dominant, or you could have been homozygous recessive, little h, little h. Hopefully you remember that if you are homozygous recessive, because this is a dominant disease, little h means you wouldn't have the disease. We also have other types of inheritance, such as incomplete dominance. And incomplete dominance, this is where we saw a blend of the traits. So you could have had a genotype, big A prime. Or you could have had codominance. In codominance, you actually use 2 different letters. So you can see the pattern A, B. You could also have sex-linked trait, and for females, you can see X, big A, X, little a. Remember that in sex-linked traits, they are linked to the X chromosome, to the female chromosome. And then in multiple alleles, that's how we described the alleles, or described the genotypes for blood types. So we'll make a little note for blood types right here. Now, it is important for you to remember these different patterns because this helps you get the best or most accurate ratios that you would need. In this first example, it says in the Punnett square to the left, big T equals tall, little t equals short. Because we see 2 different phenotypes, phenotypes is physical, and this is the genotype, the letter describes the genotype. Because we see 2 different phenotypes and we have a capital and lowercase letter, then we know this is regular Mendelian genetics. So give the genotype for the parents. Here you see 2 parents. They're both big T, little t. The genotypes, therefore, would be, is that homozygous or heterozygous? Hetero means 2 different, homo means 2 the same. So this would actually be heterozygous genotype. And specifically for this example, it was big T, little t. Then it asked, give the phenotype for the parents. Now, phenotype, again, means physical. Okay? What does the genotype actually do, or what does the genotype actually produce as far as your trait goes? So when you have big T, little t, the big T is going to overpower or overshadow the little t. Little t means you'd be short, big T means that you would be tall. So these parents would both be tall parents. Next, what are the genotypes and phenotypes of the offspring? So looking inside of the Punnett square, remember that one box just equals a 25% chance. This doesn't mean that one time that you have a child that is short, little t, that chance goes away. It means each time you have a child, you have a 25% chance of having a short child or a short offspring. So what are the genotypes and phenotypes of the offspring? If you are big T, That means you're homozygous dominant, and that actually means that you're tall. If you are big T, little t, this means you are heterozygous, and you would also be tall. If you are little t, then this means you're homozygous recessive, and you'll be a short offspring. Could have been an animal, a human, or it could have been a plant. Next question, what is the genotypic ratio of the offspring? When we talk about genotypic ratio, then you look at just the genotypes, and how many times does that genotype show up in the Punnett square? So you have big T showing up one time. We're talking about the pairs of them, the entire genotype. Big T shows up 2 times, and little t shows up 1 time. In order for me to remember how to write out the ratio, I always think of what is most dominant. So most dominant is homozygous dominant, 2 dominant traits. Then I move to heterozygous, then I move to homozygous recessive. If you didn't have big T, little t, then you might just have a ratio with 2 numbers, comparing the 2. Next you have, what is the phenotypic ratio of the offspring? So for the phenotypes, we're looking at how do those genotypes play out? Physically, what trait do we produce?
Keith Franklin, please come to the front office immediately. Keith Franklin. Teachers, if he's with you, please.
We actually end up having 3 tall offspring, 1 short offspring. Next, what environmental factors might affect the expression of these genes for height? So, if you're thinking about factors that are affecting height, this idea is going to be nature versus nurture. Your DNA, which means your DNA versus your environment. So some ideas of that. If I was meant to be really tall, but let's say I was malnourished, I didn't get enough nutrients as a child, then I might actually end up being a really small child, really short. If I was meant to be really muscular, but I didn't get enough protein growing up to support the building of those muscles, then I might not be very muscular. The next problem says some genes produce intermediate phenotypes. So when they say intermediate phenotypes, this means not Mendelian or not dominance versus recessive. So cross a pure breeding red flower with a pure breeding white flower. When you see the word pure breeding, that just means homozygous. That means the same thing. Notice that you have the genotypes with 1 letter and with your prime. It says give the genotypes and phenotypes of the offspring. So first of all, we just want to fill in our Punnett square on the top, the parents. Here we have R. Then we have R prime. This, again, is going to be an example of incomplete dominance. In incomplete dominance, remember that you have a blend occurring. Go ahead and take a second and fill in this Punnett square. What you want to do is usually we write the R by itself first, and then we write the R prime. And it turns out in all of these boxes of the Punnett square, we get R prime. So 100% R prime. Now R prime, regular R stood for my red flowers. R prime stood for white flowers. So remember the little stick should remind you to blend those colors together. And that actually will give you pink flowers. This is my genotype, RR prime. This is my phenotype, pink. Next is just to explain the inheritance of the following disorders. So I'm going to go ahead and move this. Here it says we have autosomal or sex-linked or dominant or recessive. So autosomal means not